So some people it's discussing about having some lightning talks, but what is a lightning talk out of 10 minutes talks? 2 minutes talks?
I'll discuss this briefly for like seconds on my talk. Back at Python Brazil, I have lightning talks. It's 3 minutes long at most. And if you explode, you exceed your time, everybody starts clapping to know your time is up. So you have no chance of carry on. So you give your chance to the next guy in line. But I'm not sure if we have time on schedule since we're a bit overbooked, let's call it that way.
Yeah, we were discussing about having lightning talks after the closing.
So. Interesting.
Cool. Let's see.
Check if I can improve a bit. My God, I'm paying. Not gonna get any better than that. Check.
So, shall we start? Bruno, are you ready?
I'm ready. Yeah, let me share my screen, see if everything is okay.
Yeah.
I think I'm sharing now.
Yes. Looks good.
Yes. Cool.
Okay.
You just let me know when I can start.
Okay. Yeah, so Bruno is going to show us how Dynaconf works. It's a tool for configuration management. I was having a look the other day. It looks quite cool. Go on, Bruno.
Okay.
Thanks.
So first of all, thanks for having me here. My name is Bruno Rocha. I'm from Brazil, São Paulo, and I'm a software engineer at Red Hat. I work as a quality engineer on the test automation team. I'm also a member of Python Software Foundation, a fellow member, and I do live streaming twice a week on Twitch. So if you want to see some Rust and Python every Tuesday and Thursday night, Brazil time, I'm on twitch.tv/codeshow. And first thing is, you may question, why do you need a config management library? Yeah, because we can just have simple configuration in your Python inside your Python code. But if you have a configuration management library, you can ensure that your configuration belongs to the environment and not to the code. So I will not enter into details about that, but you can read more on 12factor.net, which is a very nice guide explaining how and why you have to, it's better to follow configurations belonging to the environment. Deterministic builds and deploys are is a high priority requirement for good software quality, and having configuration separated is also nice to achieve that. And you don't want to expose your tokens and passwords in your GitHub, for example. So it's nice to have configuration isolated. So the solution that I came 6 years ago is called Dynaconf. So you can install it, pip install Dynaconf, and it's a configuration management library for Python, any kind of Python application. And it works very simple, it's very small. The idea is that environment first. So you import Dynaconf, let me, I don't have a pointer here, but okay, you import Dynaconf, and then you can start accessing your variables, configuration variables from this Dynaconf settings object. So you don't have to, you can, but you don't have to take care of creating your all configuration manager inside your project. You just import from Dynaconf, and then you start using the variables you want from the Dynaconf object. The nice thing is that envvars are the first class citizens. So Dynaconf is always trying to get this first. The way it does is, if you export any variable prefixed with Dynaconf underscore, it's going to capture those variables. The other thing is that Dynaconf parses every environment variable as toml. Yeah, toml is a very nice format for configuration, and Dynaconf also uses it for environment vars, because you know that environment vars are only strings, but you can, for example, export age, which is a number. It's going to be read as a string, but Dynaconf is going to parse, so you can do some operations, integer operations over it. So there's lots of data types you can use from toml specification. And you may ask that if I'm not having my own settings configuration on my project, how can I ensure that my needed variables are there? So Dynaconf allows you to put validators inside your project. So you describe how you want your settings to be, what are the settings that are required, and you can pass lots of rules. So before starting, Dynaconf is going to validate your settings. Also, Dynaconf can have data structures. As I said, it uses toml, so you can, for example, read dictionaries, lists, and any kind of data structure from environment variables, and you can also change that prefix. So in this example here, I changed the prefix to pizza. So you say pizza underscore database, you export a toml dictionary, and you can read it. And you can also use double underscore as Django uses, for example, to access nested elements on this. So you can use anything that toml provides. Yeah, so you can also have custom data types. If you have, for example, specialized classes or things you want to do, you can create your custom data types. In this example here, those are built-in. You can mark environment variables as JSON as being formatted by Python, so you can access Python functions or environment variables. You can also use Jinja to create very funny stuff inside to build your configuration from templates, for example. And it also has a CLI tool. So inside an environment, you can use Dynaconf list, Dynaconf init, Dynaconf validate as a CLI tool, and you are going to see without need to go to the code. If you have just a running application or a binary, you can inspect your configuration by CLI. And well, environment variables are the first class citizens, but you can also have files. So Dynaconf supports multiple files. So you can have, for example, toml files. It's layered. So you can have multiple environments like development, production, testing in the same toml file, but it can also be in different files if you want. And then it's going to read from the files if the variable is not found on environment. The format can be also YAML for those who prefer this format. And actually Dynaconf can read anything. So by default, it reads toml, YAML, ini, JSON, Python file, CFG, XML, and also you can put your custom format there. And for secrets, sensitive information like tokens and passwords, you can have a HashiCorp Vault server deployed on your cloud or on your own system, and then you can save your tokens and passwords safely there. And Dynaconf can, by default, it has functions to talk to Vault and read the variables from there, and you can merge all this into a single instance of configuration. It also comes with extensions for Django and Flask, so you don't have to do anything else than importing it. And Dynaconf is going to take place of Django settings or Flask config. So those extensions is provided by default. And well, I think I was very fast. I was afraid about having no extra time, and that's it. So the main idea is that you can do lots of other stuff, but the idea for Dynaconf is to be very simple, small, and you can configure it in very dynamic way. You can have your settings where you want, and you can customize it with your own files and data types and data sources. If you are interested, it's on my GitHub. You can search for Dynaconf in Google. It should be one or the first or the second result there. It's simple, it's small, and it's becoming very widely adopted. There are some companies using, so we use it at Red Hat. So Ansible is using Dynaconf. Many internal projects, Pulp project, and also Twilio is some of the companies I can mention here that is using Dynaconf in the projects. But there are lots of support for community. and we are open to contributions also. So that's all I had to talk. I think I have not overflowed my time here. Yeah. Thanks, everyone. So,
Thanks, Bruno.
and I don't know if we have questions, it's going to be on Discord, right?
Yeah, so there is a questions answers channel.
Okay.
Some people is also creating new rooms for the talks. So
Okay.
if you see, you can also share your slides if you like.
Okay, I'm going to share right
yeah.
now. Yeah.
There's a slides channel for that.
Yeah. Okay. That's it. Let me stop my sharing. I don't know how many times I use it, but I try to be very fast.
Nice talk. Thank you. So, who's next? Veronica? Should I say Veronica?
Start video.
Yeah. Hi.
Hello. Share screen. All right. Do you see the screen all right? I'm not seeing it on mine.
Yeah, I can see it.
Perfect.
Yeah, we're seeing the navigator bar. I'm not sure if did you change to presentation mode?
Yes, I'm in presenter mode.
This is weird. Okay, because we see the navigation bar. Maybe
I see.
you can try it again.
All right, I can
turn it off and on again. Maybe it works.
Sure thing. Presenter view. How's that?
The same. Is this
The same.
Firefox?
This is in Chrome. Having the suggestion
F11 for full
11.
screen.
Does anybody have a suggestion that's so I'm on a Mac and with the touch bar, and I haven't apparently had to use thank you.
Yeah, I don't think those have like F keys at all.
Yep.
I don't know.
Yeah, I think if you, I'm using Mac, so I think if you, if you like go to Zoom and then you can share different windows and different desktops. So if you have your full screen on another desktop, then you could choose that one because Mac have multiple desktops. So.
Okay, I'm gonna try Command Shift F as is being suggested. Okay, I see that's in.
I think it's cut
full
from
screen.
It's full screen, but it's cut on the right hand side.
Yeah, it's only like 70% of the slide or something like that.
All right. So right now I have that in another on another workspace. For me, it looks like it's full. Do you have any other suggestions? I'm not.
Do you want to share the screen again? So maybe it will auto adjust again.
Okay.
Stop
we'll try.
Again.
Okay, I'll stop sharing and share screen again.
We have time. No worries.
I'm glad. Thank you. So interestingly, now it is only offering application windows that are within this screen and not the other workspace, I think it's called.
In Zoom, you can choose if there's Zoom tab on the top, you can choose desktop. That would be your full screen thing. Maybe try that one.
Okay. So I see the entire screen, but that only shows the main screen, not the secondary one.
Do you have multiple monitors?
No, just one monitor. But I shifted the slides to a here. I wonder if put that secondary screen.
I guess if you share the monitor, the desktop, and then you switch the workspace, would that work?
Okay, let's try it.
Yes.
So right now I have both the speaker notes and the presentations on my main workspace. I'm going to share screen, and I see the option of sharing the entire screen or the application window. The preview for the application window looks like it has the slides include the bit at the top, but I'll see if after clicking on them I can make them full screen. So let's see if I do that. How does that look, friends?
Like before.
Same as
Still
before.
cut.
Right.
It's still cut.
Yeah, so something that you can try to export the slides as PDF. Can you hear me?
Export as PDF. Okay, I could do that. I had some animations, and I think it might be the lesser of two evils to show the URL at the top. I'm just thinking about my animations here. I think either way would be fine.
Yeah, because also I had this problem this morning with Google Slides. The same thing.
I see. I see. Thank you. All right. So I will export, and if anything is covered, I'll just talk through it. Thank you. Sorry, getting a little nervous here.
Oh, don't worry, it's fine.
All right. Okay, so we've got that. Let's see. I'm sharing my whole screen now. Okay. So it says that I'm sharing screen. I assume it's the whole thing. Let's do a new share and see if we can do.
If you don't load the slides on your computer, then you can open them with preview, and you can select like full
in
screen.
Preview.
Yeah.
Okay, that is something I'll try to do. Actually, let me go to downloads. Date modified. All right. And then And you're saying in preview there is a...
Yes, if you click on
If I
view,
make this...
there is I think it's the last option, enter
Mhm.
full screen mode,
Full screen.
and then
Okay.
you can share. I think you can share directly the application or yeah, the screen you're using.
Perfect. All right. And so what I will do is come over here and make sure that I am sharing just that guy. Great. And make it big. All right, friends, how does it look?
When it's full screen, it's cut again, but if it's non-full screen
Yeah.
version, it's okay.
Okay. Maybe what I can...
I think the way it was before.
Yeah, this one looks...
would be better. It looks good. Yeah.
You think so?
See this,
I can...
whole.
Okay. I can, I'll hop over there and we will just have the URL at the top if that is all right. Sorry for the trouble. I
Don't
thought.
No worries.
All right, I'm glad to hear that. Thank you. Yeah, they've been, these slides have been a whole project and a half. So hopefully it'll be good. Thanks for the encouragement.
I think it's great now.
All right, perfect.
Yeah,
Super.
looks good.
I'm so glad.
So
Excellent.
thanks, Veronica. She's going to give a talk. To comment or not, you have 10 minutes.
All right, thank you so much. So many of you have made a comment to yourself as you're writing within your code. I love all the claps on the side, thank you. And there could be a lot of reasons you would do that. You may have a variable that you are scared to change. You may have copy pasted a section of code and you aren't exactly sure what that code is doing and you want to be able to go back and reference. Or you may have made a choice that you knew you would want to explain to your future self. It's easy to forget why you wrote the code that you wrote. But when you made that last comment, did you think you were writing documentation? So documentation is what allows codes to be used, expanded, adapted, and for community to be formed. Documentation, as this image perfectly illustrates, can cause or relieve programmer pain. So when you wrote that last comment into your code, you were probably making a note about something that wasn't clear. Were you making documentation? So comments can have a lot of different purposes. They can summarize your code. They can show authorship or purpose, which is useful for folks doing a deep dive into a new code base. They can describe functions. They can clarify tricky code or unclear decisions. Is this starting to sound like documentation to you? So using comments as docs have different benefits than long form reamies that we think of as documentation. There can be a lot of different reasons to use these in-code comments, and you might think that of using them everywhere. But what's the problem with dropping comments all throughout your code? See, comments get a pretty bad rap, and all this is true. While testing can point us to possibly outdated function strings, there's nothing to help us keep inline comments up to date. So the too many comments does point to unclear code, and that's code a dev would want to comment as she wrote it or reviewed it. So it may be time to refactor. But there's something that we forget when we talk about that what should trigger a period of refactoring. If your workplace values creating over maintaining code, you won't be given time for support and maintenance. Unfortunately, a lot of the small companies that are most likely to emphasize code creation over code maintenance are a common junior dev's first job. So if you have a company that supports code improvement as much as code creation, that's wonderful. But if, like many, you find that refactoring is pushed to the back burner again and again, you probably feel you have to work yourself up to wrapping your head around some very old code. And aren't you glad that this person found time to get rid of that code smell? This comment takes on a little more nuance if you consider the rotten comments we always worry about. No longer is the message just docs can improve your community, but it takes on having outdated docs will mislead. And in fact, there are real losses that could have been avoided with a well-placed inline comment. In my research, I was told about incredible loss of data due to a dev changing a value unknowingly. Could a clarifying comment in this critical call have saved the day? So let me show you some code from a time I was struggling to learn what comments were helpful. This dirty, ugly, filthy code we can have a laugh at as by doing a game of critique those comments. In our first example, the tutorial that started this project is cited at the top, and many would find this reasonable. The comment might survive in a code base for some time and be added to documentation as the project grows. We can probably agree that this is okay. Now, in our second example, we see something a little more complicated. When I worked at MIT, my lab was a few hundred feet from a student-run climbing wall, which I wanted to be able to visit whenever it was open. Problem was, it was only open when a student decided she or he wanted to open the wall. To catch the wall when it was open, I would have to hit refresh on my browser again and again. I used Beautiful Soup for the first time to scrape the website and send it to alert for when it opened. Now, since this was my first time with Beautiful Soup, I had notes to myself listing to-dos, code that had been commented out that wasn't quite working but had worked 10 minutes ago and maybe I would need it again, and more notes expressing confusion, including my favorite comment to date. Oh, it's a list. Thank God. Would you want to contribute to a code base that had a similar pileup of comments throughout? I feel confused looking at it now, and I wrote it. A lot of people feel no comment means bad code, but our friend the cat might tell us something different. So when are we labeling our cats, and when are our comments useful? The internet, of course, has some advice. Folks readily disagree, but there are some things listed on the left that we can agree to. Doc strings should have inputs, outputs, and transformations, and outdated comments are dirty, filthy lies. Now, on the right, there's some things that are a lot more contentious, and the difficulty with all this variation is that while there's room for different styles, and sometimes style guides are provided to like share this detail, someone who is finding their way in a new code base or starting their own project and trying to do things right is going to have a lot of trouble figuring out what their correct level of commenting is and what rules they should apply. And of course, the internet is happy to weigh in on this. The advice I got when I went online and said, how many comments are too many comments, what should I be doing? Is that comments should be refactored. You shouldn't use comments. You should only use the right comments, and only your code matters. And my favorite of all, I'm supposed to just code better. Okay, thank you, internet. We're happy now. And at the time, I kind of dismissed this as, oh, there are a few jerks on the internet. But the more I looked, the more I saw that this was a common thought. So has anybody ever seen a good old Stack Overflow dry smackdown? So what happens is someone goes onto Stack Overflow, asks a very reasonable, thoughtful question, shares background, and is met with, this has been discussed to death. And I don't know what you're hearing when you hear that, but I hear something a little like this. And it's important to remember how the newest programmers actually use comments. See, newbies are trying to learn an overwhelming amount of information at once. Diane here says, I don't know WTF what I've done tonight. I don't know about you, but I want to find ways to support Diane. So some use comments to give themselves more structures, and others are worried, what if I need it back? I was talking to a dev who wants to get things working ASAP and would fork a project and begin to modify things, actually leaving themselves comments that say things like, you know, Veronica was here, come back to this, just so that as they were doing their integrations, they kind of had a place marker. So I'm considering that maybe instead of moving fast and breaking things, we should shift to move fast and write yourself some bad comments. It sounds like it's time for a poll, right? With all this confusion about what commenting, what comment practices are best. Now, since I'm very popular on the internet, I conducted one of these polls and got an entire 9 responses. So, you know, an internet poll. But I was actually quite surprised at the fact that slightly over 50% of folks said like, oh, I've always been dry, or don't repeat yourself. My code doesn't repeat. I don't need to use comments. So I decided to conduct a more involved survey. This next slide is going to have too many words. I apologize. So as I went out to go out, find some non-trivial data with my more than 9 respondents, I asked some questions about how and when folks add comments, and I also asked whether folks agree or disagree on a variety of things. And you can group these into broadly comment positive questions and comment negative questions. So, you know, comments that help me remember what my code does, those folks are going to be pretty pro-comment. And the folks who say clear code is self-documenting, they're less pro-comment. So let's take a look at some results. So folks said that, so I asked, this is out of 170 respondents, how many used, commented out their unused code, so something they were kind of using as storage because for whatever reason they didn't want to put it into version control right away. When they commented out something, some made a comment in line that they weren't certain about. When they commented each function, so our friendly doc strings, and when they use inline comments. And I was really surprised to see, after all the negativity about inline comments, how many folks were using them. Here I asked, at what point in your process do you add these comments? Like what triggers a comment, makes you think, aha, this is the time. And fewer folks said that they used them when they were learning and pairing. But most folks said that they used them when they were experimenting with a bit of code. So when they weren't sure quite what was going on, that was the time when they used these comments. And it's kind of interesting to me because the way I lined this up in the chart kind of shows what would probably be someone's project process. You know, you're learning a skill, you scope a project, and you end with completing a process. So it's kind of like when we're down in the nitty-gritty and things are difficult, that these comments tend to be added. And now let's get to our other questions. So just to orient you, on the left we have folks responding that they strongly disagree. On the right, folks strongly agree. And I asked 4 different questions. I said in the blue, I asked, my comments help me remember my code. Comments clarify my thinking in red. And these are all things that people are strongly agreeing to. So folks are like, yes, we like our comments. And finally, I ask the question, you know, you shouldn't need, I make the statement, you shouldn't need comments because your code should be clear by itself. And then people are all over the board. So it's interesting to me that we've even though we say comments are useful, I use them often and at these times, this same group of people is kind of, has kind of flattened out their opinion. They're really split on whether or not we should be striving for clean code that doesn't have or need comments, or whether comments are a useful tool. And the thing that I kind of got to as I was reading through folks' written responses to these surveys is that comments really help teach us about ourselves and where we're at in our projects and in our programming, shows us what caused confusion, what needs to be documented, and yes, what needs to be refactored. So if you're trying to support someone who is, going through this and figuring it out, I thought of some things you could do. If you're up here and you're, giving a talk and you, in the process of writing your talk, wrote comments to yourself, leave them in, point them out. Like, it doesn't have to be a perfectly clean presentation. It's okay to show our imperfections. And there's several other suggestions here as well, and these slides will be shared afterwards. So I really appreciate you coming. This is my first time surviving without a live audience, so I appreciate all the claps and stuff at the beginning. This is my information, and and thank you for your time.
Thank you, Veronica. Nice talk. So from where are you streaming?
I'm in New York City.
Oh, okay. Cool. So next speaker is Cory Jez. He's going to talk about scraping and PGA Tour golf data with Python.
Okay, let's see. You see this okay? I go full screen, is that still okay?
Yep.
Yeah, if you increase the font size, it'll be better.
The font a bit?
Yeah, now it looks great.
Good? Okay, cool. Thank you guys, everyone, for coming, and this is really cool and fun. I've been on and offline since like last night because I live in Utah, so I'm a little further behind the time zones than everybody, but happy to talk. So my day job, I do sports analytics. That's like my background. And I work for an NBA team, the Utah Jazz. But the sport that I love to play is golf. I played golf at university. I played briefly as a professional until I found out it was really hard to be a professional. So now I analyze this stuff like this for fun. So we'll do a little bit of very, very easy scraping. And for people who haven't seen read HTML, hopefully this will be nice. And then talk about some PGA Tour data. So this will be a little more like interactive analysis. I'm going to try to live code it, but except one part that takes a little while. So the PGA Tour has a data point called strokes gained. And what that is it's better than average, a lot of sports, the things that are easiest to count are sometimes not the most descriptive of performance. And so golf is like that, basketball is like that, baseball is like that. Each sport has examples, but in this case, number of putts per round or something like that might not be the best predictive measure, because if you hit the ball really close to the hole, you'll have less putts, but that's because you were good with your irons and not with your putter. So strokes gained was developed at Columbia University, and here's an example. This is the 18th hole at TPC Sawgrass, and a player, it's a 446-yard par 4. On average, it's going to take a pro 4.1 shots to finish the hole. If Ricky Fowler hits his tee shot in the fairway up here somewhere 116 yards from the hole, when you're 116 yards in the fairway, your average strokes needed from there is 2.82. So 4.1 minus 2.82 is 1.275 minus the one stroke that we took to actually hit the ball. And so we have a strokes gained of 0.275. So it's relative to, all golfers in these similar situations. And the metric's not perfect, but it's a good way to measure player performance. And so what we're going to do here is scrape some of this from PGAtour.com and very simply scrape it. Don't even have to use Beautiful Soup or anything like that. And then do some really quickly look at it, and then maybe we can see if we can build a predictive model. So this is what the website looks like. You get the player's name. This is the strokes gained off the tee, and their average and total and how many rounds they've played. So you're getting, these are some of the best drivers of the golf ball. So it's not just long, it's long and accurate. It's kind of what you want to be there. So to scrape this data, we'll do some very easy pd.read HTML. They had a really funny thing. I wrote this code back in September, October, and they changed something in their, I'm not really a web developer, but they changed something in their table headers, and they threw in this very random character that we had to strip out. But obviously for folks who are familiar with scraping data, you'll spend a lot of time inspecting the HTML, and so something we had to do here. So all we're really going to do is loop over all the types of reports and the years and return data frames for it. So really, really easy scraping from their website, which is really nice when you have a table that you can scrape. And like any good data science project, most of it is data cleanup, which all of this does. I've already posted this in Discord, and folks can follow along the code. It takes about 2.5 minutes, 3 minutes to scrape, so we're not going to do that. But we'll pick it up here. This is what our resulting data frame looks like. So now we've got, here's an example golfer, Dustin Johnson. All of his data from, he's been on tour since 2009, and as well as the money he's won, which is something we're going to try and predict later. So we can do some exploratory data analysis. And the question we wanted to ask here was, golfers have started driving the golf ball a lot better. They're bigger, stronger athletes. Tiger Woods came along, people got into fitness, the technology and golf clubs are getting way better. They just hit the ball way further and they're better at it. So I wanted to see if we could do some time series exploration with Plotly and see if we could kind of understand that. So this is the 4 kind of parts of the game: off the tee, approach, around the green, and putting. And the off the tee, which is the metric I was interested in, the blue line is the average of the top 10 players each year. Red line is top 25, and the gray line is the average for the entire PGA Tour, which is obviously around 0 because this is metric is like relative to everybody. So, and the thing that was interesting here is you kind of feel and see the blue line trending up, and the red line maybe a little less. So I zoomed it in here. And we can really see this, again, this blue line over since 2010 is really trending up. So this is kind of supporting our hypothesis that the best golfers in the world are driving it better, especially relative to their counterparts. So to get good as a PGA Tour player, you need to get better at driving the golf ball. The other thing we wanted to look at is how stable these metrics were year over year. So if you were trying to do something predictive, which is what we're going to get into in a second, how stable are these things and how stable are they relative to each other? So just looking at year over year for every player, so about 130 players a year over 15 years, so a decent sample size. We have off the tee, so the driving part has an R squared of 55, all the way down to putting an R squared of 28. So, it's really interesting that putting is not more simple, but a very, very important part of the game, but it's more, about twice as volatile year over year, as opposed to if you're a good driver, it's pretty predictive of how you're going to be next year. Whereas you could be a bad putter one year and a good putter the next. So really interesting takeaway and kind of lead into the modeling. So it's not going to be anything complex from a modeling standpoint, but kind of a basic check some regression assumptions and maybe see if we think it's a good regression model, or if we think it'd be something like a random forest that we should do with this, and then really see if we think this is useful in trying to predict performance. Use cases here, if this was, this is at a season level, but at a tournament level, if you had something like this, you can use it to gamble, you can use it to, do all sorts of different things. So first thing we want to do is account for inflation here. And we're just, because the money given out in 2005 was very different than 2018. So we just create a, coefficient based off 2018, scale it to that. We do want to do our predicted variable is going to be this money per, which is money divided by events played, because if you just play more events, you win more money. So the money list is kind of the PGA Tour's way of the standings or the points earned, what might be in it. You earn points in football in the Premier League. Money is how they kind of calculate how well you've done throughout the year. So let's look at all of our inputs. So we're going to look at all of last year's data for a given year, as well as the money the player earned in the following year. Seaborn pair plots are really great ways to do this. It's also allowing us to check some regression assumptions here. So none of the variables are too correlated with each other, off the tee and approach a little bit here. Also with our money metric, they're not nonlinear, they're not perfectly linear. So our linearity assumption, which we're looking at right here, kind of holds, but not perfectly. The one that's big is normality. So when we look at, this is our target variable, and it's obviously not normal at all, very right skewed. So we're going to take the log transformation of that, and we'll see in a second how that affected the model. So taking the log transformation of our output variable, which is a very common thing in regression, looks a lot better. It's something we can predict on now. So the last one's homoscedasticity, which is basically saying your residuals should be normally distributed. So here we're just plotting residual, which is the error, against the predicted value of a basic model that we built. And we see this nice randomly distributed plot. So we pass, or we think we don't violate homoscedasticity there. So now let's do some train test splitting, and we'll look at why we wanted to predict on that normalized, not the right tail. When we predict on the right tail, we get pretty ugly errors. For guys who are actual $400,000 or $500,000 per event, our model just doesn't predict that high, because that tail just doesn't allow it to. Whereas when we predict normally on the log, we get a nice kind of, and we still have some error there, but it's a lot cleaner. So then we'll do some cross-validation just to kind of understand it, hold out each season, just in a loop here to do that. And then, so our cross-validation score is about 714. So now we've got something we can compare to like a random forest. So in this random forest, this is just kind of, built linear regression as our base. Does random forest get you better? Run the exact same cross-validation for the random forest, so you're running it about 15 times. And interestingly, the random forest cross-validation score is actually higher. So it feels like it's a really good data set for linear regression. So the very last thing we're going to do, we've kind of decided linear regression is the model we want. The complex black box model didn't seem to do any better. And what we're going to do is actually just fit it on that basis on the data and predict on 2019, which is the last full season that we have. And here's our predictions against the actual money per. These are just the top predicted players in the world. So it got the #1 player in the world right. It predicted them, actually predicted them a little higher. When we look at our big misses and our errors, our average error is 63,000. So about half of the mean of the data. So not awful, but not great. We're like a 0.5 NRMSE. The one interesting takeaway is that everyone we missed on, we predicted way too high. So these are our top misses in the prediction in that test set. And, we predicted 50,000 when we got 8, or 40,000 when we got 8, or 55 when we got 14. So, we might come back and do some transformation on our data to try to clean that up a little bit, because we're missing on the low side of guys. And the last thing we can do is look at our coefficients. So we do have to exponentialize our coefficients, since we run a log transformed output to get the impact. And this kind of just reconfirms what we said at the beginning, that driving off the tee here is way more important. And it's got, its coefficient, its impact here is almost twice that of any other coefficient. And so if you're coaching a player, hey, for every 1/10 of a stroke you gain driving in this off the tee strokes gain metric, you could expect a 20% increase in running lanes, all those being equal. So it's a really, this is an interesting way where you can take different players and look at the coefficients and maybe help coach them, develop practice routines and things like that there as well. So, and here's pizza I had for breakfast this morning because it's only like 12 noon or so here. So thanks very much. Sorry for running a little long. Thank you guys. Stop sharing.
Thanks.
Thank you, Cory.
It was a great talk.
Thank you. And I'll be in the Discord if anyone wants to talk.
Yeah.
Do you think it's harder to predict basketball or golf? But you can answer that on Discord.
Yeah, I'll the answer is basketball, but I'll talk more on Discord.
Okay.
Yeah.
So the next speaker is Vinícius. Are you ready? You're good.
You.
Yeah.
Let me share. Where are my slides? Hang on. Let's see, where are they? Over here. Okay, share. Can you see my slides over there with the title?
Yes.
Great. Just let me
And the
reset
navigation
my title.
bar. But
yeah, but that's okay. I don't mind it. Is it bad for you?
no.
Okay, then I don't mind. Let me just reset the timer on the notes. And okay, let's do it. Well, thanks for the opportunity, guys. I'll talk about now a project me and other volunteers work about translating Python documentation for Portuguese language. For those who do not know me, my name is Vinícius Gubiani Ferreira. I work at Asion Technologies, the company at the top left corner of the slides. Asion is a CDN platform which works with edge computing and serverless technology. I'm a Python developer at Asion. I am/was a cyclist before the pandemic, TV, movies, and series lover, addicted to perfectionism and quality assurance, and an open source contributor now with this project. How did it all started? Last year, in October, November last year, I traveled to São Paulo for our biggest Python conference in the country. And over there, I saw many amazing talks. And among one of these talks, I photographed several of them. I photographed this lightning talk of the guys discussing the translation project for Python documentation. And I stored it on my cell phone. And when I got back to my hometown, Porto Alegre, I decided to check it out several other projects, including this one. And I look at this project, I can contribute with this, I'll give it a go. And the first contact I attempted to make with the guys wasn't very okay because the README of the project wasn't very clear on to how to get started. The first contact I had was through some open issues on GitHub. And over there, I asked him, how can I help? How do I get started? How do you work? What needs to be translated? And after some messages from one of the developers, one of the volunteers, they redirect me to the place where all the guys hang out and chat, which is a Telegram group where we have our long-running discussions. We don't communicate on a daily basis. Our average is almost something like 3 or 4 days. On average, we exchange at least one message, usually regarding tough words to be translated. I remember from day one, since I joined the Telegram group, the guys opened a Telegram pool to discuss how should we translate the word deprecated, which quite doesn't mean the same thing as depreciado in Portuguese, which sounds a lot like a financial economic term. Can't remember right now how we end up translating it, but I remember everybody was posting book references and authors. So this is one of the things that most caught my eye from day one. which is the opportunity for anyone to join in, to say what's on their mind, to speak up, to participate, no judgment at all. And I thought from day one, I felt like home. Another interesting feature we have on our Telegram group, we have a translation bot developed by one of the guys. It's called I17 bot, which gives us a daily reminder, if you opt in, of course, of text that is not translated from the Python documentation. It also shows us the statistics on a weekly basis to see where we advanced, where new translations came up. And it just got this week a new feature to help new guys to learn how can they participate into the project. Where the translation itself happens on Transifex, which is a platform dedicated for translations specifically. Originally, I didn't like it very much. I like to work offline without internet, even sometimes don't like to rely on power sources. So after the guys told me about the effort that would be to work offline, I decided to give Transifex a go and ended up liking it a lot because it have mostly a glossary to help us out with difficult words. So it's awesome. I recommend it. If you have any open source projects, try it out because they don't charge open source projects. One of the things I asked guys a lot is, when does translations go live? How can I see my work and show other people? Nowadays, I can explain that. It happens using GitHub Actions once a day during midnight, if I'm not mistaken. It passes a pipeline to check if there are no errors or warnings. If it all goes well, it uploads the translation to the main Python repository, and it goes live into documentation pages. This graph represents a lot for me as a New Year's resolution. I decided to participate, to engage more in open source projects. So we can see the guys always shows that during events such as Python Brazil, which happen in October, November, we have small spikes. And after the New Year's Eve, we saw that many people actually engage into the project. So it's very visual. And some people ask me how much is translated. It's only 28, 29%, which is not a lot, but it was only 20% back in October, November. So a 10% increase in 6 months, it seems a lot to me. And we have an inside joke that our Portuguese is the 4th most translated language. We have an inside joke that our current goal is to pass the French language. So watch out, France, for coming for you. And after that, Chinese and Japanese language, which are the 2nd and 1st most translated language. And some of my friends ask me, why do we do it? Do we do it for the money? No. Do we do it for the fame? Also no. I cannot lie that I got some perks doing this job. I was able to sign on as a Python Software Foundation member, which means I dedicate at least 5 hours a month into translating. On a daily basis, I do a single text translation, but on the average, I believe I do engage more than 5 hours a month. And with this signing, I can vote for PEP's approval and the biannual board of directors election. I also got a chance to sign my name into Python itself. If anybody checks out the documentation, the repository, my name will be there spread across some other places that I've worked. To participate in awesome events such as this one. But most important of all, some of the things that I consider are the most important with this project, it's a chance to engage with the community and to pay back for something that we borrowed for free. I wish I could donate money to the Python Software Foundation, but unfortunately I don't earn in dollars, I earn in reais, which is, I guess, the worst currency ever. It's not very good. And the most important thing that I consider this project, we're helping others to learn, because not everybody speak or even read English fluently here in Brazil. I don't have an official number, an exact number, but I believe something like between 5 and 10% of developers, or even any other personnel that don't work in IT, don't speak any English at all or read any English at all. So this project help them to achieve what they want with Python. At least I like to think it that way. And the key lessons learned I've got from this project is it's very rewarding and fulfilling to have the sense that you are helping other people, even though you don't met them directly. I never even faced any of the guys that work in this project directly, never seen them personally, only on a long distance at best. And open source doesn't have to be exhaustive. I work on a daily basis, 1 or 2 sentences at most on a daily basis. Sometimes during weekends I get tougher, work more. And it's easier to participate than it actually looks, because everybody is very welcoming. They actually want your help. And I believe this applies to other projects. Well, guys, my time is almost up. I would like again to everybody, as we say back at ASION, move to the edge. So, valeu, merci, thank you, muchas gracias, vielen danken. And I'm not going to be able to pronounce the last couple of 3. So if you speak Russian, Chinese, Japanese, please do pronounce them. If you feel like contact me regarding this talk or any other subject, any open source project translation, please do on any of these means or even on Discord. I love to receive any feedback from you. And I'll be posting on one of the rooms a link with a code, so you can sign in to try ASION services. I guess it is $300 to spend on ASION during 1 month, 3 months, something like that. Thank you again, guys. See you.
Thank you. Obrigado, Vinícius.
Thank you.
So next speaker, we're a bit late, so we are kind of 10 minutes late. So the next speaker is Max. Are you ready?
I'm here.
Oh,
can you see my screen?
Ready? Yes.
Awesome.
Cool. So
well, we have another web scraping talk. This one I hope will be a little bit different. Whereas the first web scraping talk examined Scrapy, I don't think I'm smart enough for Scrapy. So in going through the Scrapy documentation, I see things like XPath, I see things like CSS, and I see things like generators, just to spin up like a very simple example. Going a little bit deeper, if I want to get Scrapy off the ground, I need to know what responses are, like where did that response thing even come from? And I actually have to run this thing from the command line. That's not how I code. I code interactively. I need to touch and feel things. And so reading through Scrapy and actually trying to scrape a website with Scrapy has me just scratching my head. I really just can't get these things off the ground. And so this is the focus of the presentation. How can we do web scraping for like the everyday person? And so we will not be talking about Scrapy, because besides the boilerplate, the CSS and the XPath nonsense, just to download it to your computer gets you 25 different dependencies, grabs about 100 megabytes of code. And if I were to go onto the GitHub page for this tool and wanted to discover a little bit more, I'd have to sift through around 1 million lines of code. And so we will not be talking about Scrapy. Instead, I'd like to introduce you to a tool called Gazpacho. So what is Gazpacho? Gazpacho is a tool that is open source. It's about 100 to 200 lines of code. There are 0 dependencies. You don't need to know XPath. You don't need to know CSS. You just need to know Python. And you just need to focus your attention on one method. So what are you trying to do when you're scraping a website? You're trying to find things. You're trying to find and isolate things. And so that's all you're gonna have to know. You're gonna have to know how to find things. This talk and what I'm running through right now is available on my GitHub. So if you'd like to follow along or play with these examples afterwards, you can grab this script right here. And let's actually demo it and see what Gazpacho can do. So I want to scrape a website like Wikipedia. Looking at the Wikipedia page, I can see a couple of things. There's kind of links everywhere. If I want to grab the headers, I'd have to actually figure out what these things are. And so the basic tool of a web scraper is to open your browser and look at inspect element. So I'm seeing that if I mouse around, these headers are in these H2 tags. And if I click on a link, if you know anything about HTML, you'll know that links are stored in A tags. Well, Gazpacho just has you looking at those two different things and asks you the question, okay, what do you want to find? You want to find A tags and you want to find H2 tags. So after installing it and bringing in its two component parts, get and soup, we will target the URL for that specific Wikipedia page and wrap the URL in this GET request. We'll be left with some HTML code. This HTML code will then be wrapped by this soup object from Gazpacho, and will all of a sudden make this thing parsable. So if I want to find the A tags, well, shoot, all I have to put in is, hey, find me the A tags. So here's every single link on that page. If I want to find the H2 tags, here are the H2 tags. If I want to find just the first tag, you'll notice that the behavior of Gazpacho is to give you something that's interactive and will actually just work on the fly. So if I wanted the first H2 tag, I can adjust the method and ask for mode at first. Here's the first H2 tag from that Wikipedia page. It had this H2 tag with contents inside. If I want to isolate that text, I just ask for the text attribute. Attributes are also stored on this soup object. And so if I want to peel out the ID for this asset tag or this HTML element tag, all I need to know is Python, and all I need to query is a dictionary. So I'll peel out the ID key. Gazpacho also has an ability to filter on specific tags. So if we were to go in and filter on tags that had this class MW headline, I could actually go back and say, hey, can you please just adjust the query, find all the span tags where this is true. And so here are all the sections, and I can run through and grab the text for each through list comprehension. This is a quick little library that does pretty printing. Pip install rich, highly recommend it. But in the interest of time, I won't explore it. If I'm looking at the Wikipedia page, I might want to scrape specific links, not just all of them. So looking at the tags over in this toolbox over here, I might try to isolate and grab something like this NV frame 2 or nav content hlist. I'll try a couple. My first attempt will just return way too much. And so I'll have to go back and filter things a little bit. The nice thing about Gazpacho soup is it allows you to chain finds together. So actually I've decided to target the table tag with this class. I can then find the unordered lists inside of that, grab the first, and then find the A tags nested inside. And so then grab from each of those links, the hrefs on top of each to grab them all. Now I want to scrape the actual content from the conference website. So I think this was actually done this morning. I'll do it with the Gazpacho flavor. Looking through how this is structured, I'll click on someone's name, inspect element, and see a couple different things. So it looks like every single person in talk is in an LI tag with the class schedule item. And then some of them have these class schedule item smalls. That's going to be important in a minute. But if I go in and grab soup and get from Gazpacho, target the conference website, force it into HTML, print it out, I'm left with this situation where, shoot, I need JavaScript. Well, I don't want to learn a different tool. I don't want to be frustrated and left kind of in the lurch. So instead, I'm actually just going to lean on Selenium just to spin up a browser under the hood to actually target and grab the rendered page and then shove that into Gazpacho. So this code allows me to spin up a headless browser that's using Firefox. All I'm going to do differently is replace the Gazpacho get with Selenium's get. So I'm using the browser that I spun up here, grabbing the page source, and then stuffing this into the Gazpacho soup. And now I can use Gazpacho as normal. Target the LI tags after the page is fetched. Go in and not grab all the LI tags, but only for where this is true. So class schedule item is right on that LI tag. I'll then isolate the first just to peel out, let's say, the talk title and the presenter's name. And so I'll grab the H2 text, the A text where the target is blank. So you can see there was the H2 class. Here was the talk presenter. And then I'll just run this through a function, test it on the first, and run it over everything. Unfortunately, I've hit an error, and the error happened on this LI. So actually, this person's name was not wrapped in an A tag, it was wrapped in a P tag. So for that reason, I'm going to adjust the function and actually use a try and accept that will first try the A tags and default back to a P tag if that failed. So I'll run this, run it over everything, and grab all of the metadata for talk titles and talk presenters for this entire conference. So that is Gazpacho. A couple plugs. You can find me on Twitter at Max Humber, on LinkedIn /in/Max Humber. I also have a couple other open source packages, one called GIF, which allows you to do animated visualizations in Matplotlib very easily, as well as a Markov chain generator called Mark. I hope you check out Gazpacho, GIF, and Mark, but that is my time. I hope you found this valuable. Thanks so much, everyone.
Thank you, Max. Nice talk. Yeah, so we are a bit in a rush. So no time for questions. Next one is Daniel. Are you ready?
Hello. Yes.
Hi.
Let me just get the computer sound. Okay. So can you hear me? Can you see my screen and hear me?
Yeah, it's kind of blinking.
Okay. Let me see.
Nice, good. Seems so. Yeah.
Okay. Hello, and thank you for having me. My name is Daniel Jordán. A little bit about me. I'm from Peru, but currently living in Canada. And I studied music and I studied physics, so that's where this talk kind of comes from. My passion for both music and computing, which I did a lot during the physics study. And I can actually say that the random module from NumPy is one of my musical influences, because this is all about randomness. So the origin story of this project is that I was already using the random module to generate lists of random numbers. And one thing led to another, and I just started doing matrices of random numbers like this. And a funny thing that happens is that when you get a random matrix, so a two-dimensional array, and you square it, you raise it to a power, you start getting, first of all, obviously larger numbers. And then you start getting something that seems like a pattern that starts to emerge. If you can see the pictures, they start to converge on a certain number, on a certain pattern, sorry. So the image has reached what you would call a steady state, which is basically just happening because the multiplication, the matrix multiplication is happening row to column. The lower numbers are pulling down the bigger numbers, and the higher numbers multiplied by a higher number are pulling them up. So you get this kind of image emerging, except when you get overflow. If you work with ints in NumPy, you're gonna get overflow pretty quick and the pattern will just break up. But all we care about is the relative magnitudes between the different numbers. So we can start with an 8x8 random matrix with floats, and pretty soon you can see that by the third iteration of raising it to a third power, we already start getting a steady state, a constant pattern. And the thing about this is that, to me, it reminded me immediately of a step sequencer. And a step sequencer is a device where each step is a tone, and then you have different tones, and you can adjust the pitch and everything. So you can start making out melodies or patterns and use them to make music. So that's what it reminded me, the 16-step sequencer to a 4x4 matrix, which has 16 steps. And this is a 4x4 matrix raised to the 10th power. So this is the final steady state of this matrix. And what I did is I followed tutorials by programmer Alicia Key, which you can find at GitHub at akey7, used the sound device module and created the random matrix music maker. And previous apologies to those with perfect pitch in the audience, because this is gonna be random frequencies, just that sound like this. So hopefully everybody can hear it, right? And this is a representation, a visual representation of another matrix. You can make any kind of matrix. You can start from a seed or make them randomly. And it's basically a tool for musical inspiration. You can get these tones and these different arrays and mix and match them with other sounds to make patterns, new melodies. So you can make any kind of new matrix like this one, for example. So you can see there's like there's kind of patterns that start emerging. Like you have a darker color, a darker row with darker row, and then a higher or less dark rows. But there's also a kind of a break in the middle of the columns. And you can also shift the frequencies to actual musical notes, so you can have something that sounds less abrasive or less strange. And you can also use different frequencies to make something like a bass track. And they sound a lot like Nintendo or 8-bit sounds, because it's just basically working with sine waves, which is like the most basic kind of sound. But you can also have some pretty interesting effects from just choosing these random frequencies. Right? And if you like what you actually played, you can actually loop it to make something like so you notice those two really low notes that started happening on the 5th and the 10th or the 12th beat in this pattern. They kind of add a little bit of rhythm to the melody. And you can also use this to make some interesting like video game type effects that sound a little bit more chaotic. And it's just something that, a little passion project that I did in a couple of days, because just messing around, just to make something interesting and find inspiration for music and for learning new things about coding. So if you're interested in like playing around with this, making your own sounds, making your own melodies, you can find the project at GitHub at Random Matrix Music Maker, and I'll be in the Discord for any questions. Thank you.
Nice talk, Daniel. Thanks. Yeah, so feel free to ask in the question and answers channel for questions. I was a bit afraid of the sounds, to be honest. So the next, Jocelyn. Jocelyn is going to talk about a decentralized storage network and Python bindings for it. Are you ready, Jocelyn?
I don't think we can hear you.
I think
yes.
she's muted.
How about now?
Yeah.
Yes,
yeah,
much better.
Okay. All right. So apparently the secret is you need to unmute yourself. So I think we all learned something today. Hi, everybody. I just thank you for having me here. And I also just wanted to give a shout out to Python Pizza. I think it's amazing that we've raised so much money for Doctors Without Borders. So I kind of want to give a hand to you before I start. I'll try and move through quickly. Let's see if I can start my little timer here. And can everybody see my screen first off?
Yes.
Okay, great. Thanks for confirming that. I am going to just slide a couple of things over around my window. So today, the topic is Python bindings for a decentralized cloud object storage platform. And I know that's a big mouthful of words. So my name is Jocelyn. I'm the community manager at Storage Labs, and we have a platform known as Tardigrade. And Tardigrade is similar to the mainstream larger cloud storage providers that you may have heard of before. Some key differences are that we are open source and that we are decentralized. We have end-to-end encryption baked in, and nothing goes up from your machine until you've encrypted it yourself. So we never even see the unencrypted form. We have a supply and demand side, a little bit like an Uber model. So the decentralized aspect is your pieces get stored on machines all around the world. And then the demand side is obviously people who want to code and store stuff. To just help understand the life cycle of a file, files get split into segments. Segments are striped, and then those are broken into erasure shares, and then those get distributed among what we used to call farmers. Those are the nodes of the decentralized system. So what I wanted to do today was a live coding demo, and like Murphy's Law, I've just been having every imaginable technical problem that you can have. So I sort of quickly refactored my slides. If anybody wants a live demo, my email is at the end. Just reach out to me and I can set up a one-on-one. But it was just looking kind of risky given a lot of issues with my screen and sharing and whatnot. So let's see here. So Uplink CLI is a command line interface that allows you to access object storage from the command line, and it also lets you manage permissions and sharing. So the graph helps a little bit, the diagram helps a little bit for people to understand that stuff goes from your machine to the uplink, it goes to the storage nodes. And we recently finished the libuplink Python binary library bindings. So that means anyone that wants to use us as their storage layer on a Python application can integrate more easily. Libuplink is a developer library that's written for the Go language, and it allows you to integrate with the object store programmatically. It has a bunch of different components, pre-written code, subroutines, classes, values, and type specifications. We have it for Go, Python, Swift, Android, and Node with more stuff coming. Obviously, what we care today about is Python. It's available on GitHub. And it's actually, it's so simple to use that I wish I had actually included the live coding. You basically just install uplink C Go package, and then you install storage Python. After that, you clone the Go package and navigate to uplink C folder in home. Then you run go build, import uplink Python to include it in your project, and then create an object of libuplink py class to access all the functions of the library. Whoops, yes. It also comes with a file, hello storage, and that's found in the folder where the Python package was installed. The sample code will call the file and upload the binding class and do all the following cool stuff. You can list out your objects, create a new bucket, write files from your machine to the storage bucket, read back from the objects. You know, like you can put it up, you can bring it down, you can list out your objects, you can delete stuff. We do have something, we have shareable access that's implemented with macaroons. and the cool things about macaroons is that you can actually, they can actually be chained. So you can get really specific with your restrictive access rules and, you know, list and do stuff. So when you do get started with the system, you have a choice of what satellite to use. So some people prefer to use, most people go by geography, to tell you the truth. They just kind of pick the one that's closest to them. But if you have specific reasons for wanting, you know, stuff to be running through Asia, stuff to be running through Europe, or stuff to be running through the US, we can facilitate that. Everybody, the sign up form is self-explanatory. I don't think I need to break that down. And again, if anybody's interested in a live demo or, you know, working through some stuff together, I'd be happy to just, you know, shoot me a line. My email is jocelyn@storage.io. And thank you so much. Wow, that went faster than I expected. But that's the end of my talk. So thank you so much for having me.
Thank you, Jocelyn.
I was talking too fast.
That was good.
Thanks very much.
So how safe is my data in tardigrade?
Yeah, that's the first question everybody asks. They're like, wait a minute, what? It's safe because the encryption is baked in. So like it doesn't even go anywhere from your machine unless it's already been encrypted. And since it's encrypted by you, we're not able to ever see it. And then I think
but what about data loss and data
yeah,
loss?
so we do erasure encoding. We use Reed-Solomon. And so every piece is everything that goes up is broken into, we've been playing, you know, in the past before we settled on something, we played around with different ratios. Right now things are broken into, I believe it's 80 pieces. And I believe we need 29. Well, I know it's 80 pieces. I believe we need either 29 or 30 of any given file to reconstruct the file. So we conduct audits like all the time. And if stuff needs repair, then we do that automatically. And then Reed-Solomon, probably a lot of people here might be familiar with it. For anyone who isn't, it's pretty old and pretty solid. It is the thing that lets you, when there's a scratch on a CD, like still play the CD. So between that and the encryption, stuff is actually pretty stable. And I know that's the first question people always ask, because it sounds crazy on the face of it, but it actually is like surprisingly robust. And the reason for that is because we operate in a way where you can't trust anybody. It sort of creates this super harsh environment where you have to consider all of those things first. It's not like a more traditional model where, you know, most stuff is okay most of the time, and then when issues crop up, you can kind of lock it down. We kind of come out of the gate with a situation where potentially everything is completely at hazard. So we sort of, instead of like moving towards that conclusion, we just assume that everything is completely unsafe and work backwards from that. I hope that answers your question.
All right. Yeah, more or less. Thank you. Thanks a lot for the talk.
Thank you.
Next is Moshe. He's going to talk about everything you wished you didn't have to know about numbers in Python. Oh. Are you ready, Moshe?
Yep, ready. Just sharing my screen. Oh, that's not what I wanted to do. Sorry. I'm going to share the whole desktop because that works better. And then go full screen here. Just 1 second. Enter full screen. Okay. Is it projecting okay?
Yes, nice.
Okay.
Beamer.
Awesome. Okay, so I'll go ahead and start. So my name is Moshe Zadka. My website is cobodism.com. where you can find out pretty much everything about me. And today I'm going to be talking about everything you hoped you'll never have to know about numbers in Python, but you really do. First, I want to start with acknowledgement of country. I'm streaming from San Francisco Bay Area, which is the ancestral home of the Mueca Ohlone people. Okay, so I'll start with talking about numbers in math. So God gave us the natural numbers, and the rest of it, we really have only ourselves to blame. Leopold Kronecker phrased it a bit differently, but I think this is a better attitude. So we have the natural numbers. Mathematicians always begin them with 0, so it's 0, 1, 2. Then we have the integers, which includes negative numbers. We have rationals, which are numbers like half and 3/4 and 5/4. Then we have real numbers, which is a really weird category, but includes useful numbers like the square root of 2 and e and pi. We have complex numbers, which is what happens when you add to real numbers the square root of -1, which is sometimes called I, but in engineering and sometimes in programming is called J. And maybe quaternions or numbers, right? When you add I, J, K, and you actually have more than one square root of -1. And whether the numbers are not, I'm really not sure. The category of number is weirdly hard to define. Well, but we are all using Python. So let's talk about numbers in Python. We have int, which are kind of sort of like mathematical integers, but not quite. We have floats, which are kind of sort of like real numbers, but not quite. We have complex, which is adding to floats the square root of -1, but so they're kind of like complex numbers. We have fractions, which are kind of sort of like rationals. We have decimals, which are also kind of sort of like rationals. And is GMPY2 numbers, and it's a third-party package, but it's kind of like works like a number. And so the category of number in Python is also just as hard to define. So let's start with what you probably think of as the simplest numbers, which are integers. So let's say that you only type integers in your source code, and you only get integers from output, and you validate that everything that goes into your program is an integer. Great. Then you do a division operator somewhere in your code. And you'll notice that even though the value is equal, right, it's 4.0, right? It's very easy for integers to become floats. And you're probably thinking, well, you know, I validated everything that came into my integers are. So everything that came into my program are integers. There's gonna be some floats in the mix because I might have done a division somewhere, or a library might have done a division somewhere. But that's okay. How problematic are floats? Well, floats are great, right? All you need to do to understand floats are just to pay $100 for the IE 754, which is a standard, which is kind of how float numbers behave. If you paid it before 2019, you need to pay it again because they revised it and changed a bunch of stuff. It's just 70 pages, so you just need to read them and, you know, memorize them because you'll be using that day to day. And it's a very straightforward standard. I just, you know, they say don't put, you know, really complicated sentences in the presentation, but this is a very straightforward sentence. I'm just going to read it out loud. Round ties to even is when the floating point number nearest to the infinitely precise result shall be delivered. If the two nearest floating point numbers bracketing in unrepresentable infinitely precise results are equally near, the one with an evenly significant digit shall be delivered, which is very straightforward and explains why it's called round times to even. And the standard is full of phrases that are just straightforward, so you shouldn't have any problem reading all 70 pages and memorizing them and using floats. I neglected to do that. Unlike I'm sure most of you who all read the standard and memorized it. So I was surprised by some things that would never surprise anyone who memorized the standard. So I'll share with you some of the things that surprised me. So as you can see in the first line, 1 + 2 - 2 - 1 is 0. Mostly that shows that Python parses it the way you'd think it parses, right? Because parsing does not depend on type. So you'd expect that or at least I would expect that 0.1 plus 0.2 minus 0.2 minus 0.1, where you add stuff and then you remove exactly the same stuff, you would get 0. But you do not get 0, as of course the IE 754 explains. You get something that is kind of small, but not 0. But that's okay. You know, why should you expect that adding something and subtracting it will give you the same number? Maybe you think that the law of associativity is correct, right? Where if you do a plus 1, it's the same as doing a plus 1. And if you give this value, 2 to the minus 53, get that a plus 1 is not the same as a plus 1. That's fine, because I'm sure that everybody here has memorized whether the right side or the left side is how Python parses by default. If you just type, as I'm sure all of you have typed at some point in your code, just a plus b plus c without any parentheses, I'm sure you all remember which side Python parses it. I would have thought that it doesn't matter because the value is going to be the same, but the value is not the same. As you can clearly see, the value is different. So there's a bunch of things that would surprise the unwary person. And you might think, well, you know, that sounds kind of a bit fishy to me. Maybe I should just use floats in my code, right? Fractions are straightforward, right? Rationals don't have all these problems. Rationals are straightforward. I'll just use rationals. And maybe you sometimes want to add a bunch of numbers together, right? That is reasonable. So I want to add 10,000 numbers. So this is literally just 4 zeros here. So it's 10,000 numbers. I use the Python function for sum. And I calculated how long it took. It took 1 minute and almost 10 seconds. The size of the output was a little over 90K. And if you wanted the approximate value, I would have printed the whole value, but I literally didn't have enough room in the slide to push 90K worth of data. I would have had to use really, really small font, and I'm not sure how that would look. So I put the approximate value, and the approximate value is 1.25. It's basically adding a bunch of inverses to a certain series that I can talk about later, but it's just 10,000 numbers. And, you know, you can think, you know, Python is not the most efficient language, right? If I really cared about performance, I wouldn't use Python to add, you know, 10,000 numbers, and it wouldn't have taken 10 seconds. But let's see what happens if I try to do the same thing with floats. So as you can see from these two slides, the only difference is that now I convert each of these fractions to floats before I start. And now it took so little time. This is still Python. This is not Rust. Same language, just added float here, right? Same language. Now it's so little time that at this point, I don't think the measurement methods are useful. I should have used time it. Time it, what it does is it runs the stuff in the loop. I didn't have enough patience to wait for 1 minute and 10 seconds to run in a loop, because this would have been 10 seconds. And let me tell you, while it was doing, the CPU was churning and my laptop was kind of getting hot. So I was kind of starting to be afraid I'll damage my kind of expensive laptop. It's a nice gaming rig. So I really didn't want to do it for 10 minutes. This I would have used to use time it, because it takes so little time at this point, the measurement methods, but it's like less than 1/100th of a second. It's like a little over 3,000ths of a second. And as you can see, it's a different number, right? I'm sure you all memorize the number, so it still starts with 1.253, but it's a different number. And that's because floats are inaccurate, right? As you can see, as we've seen earlier, when you do calculations with floats, sometimes numbers get mangled about, and it's a different value. And for those of you who are not, great at memorizing numbers, between these two slides, I put a comparison slide. So this is a comparison slide. This is a precise value on the top. This is the imprecise value on the bottom. And I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. So 14 places after the decimal point is where the first error is. If you don't know what 10 to the minus 14 is, if you measure the distance from the Earth to the moon, it's about 1 millimeter, so a grain of sand. And if you need to you know, something as rough as just sending a rocket to the moon, and you want to make sure you have a buffer of a grain of sand, then, you know, that's not a problem, right? But clearly, like most of us need stuff more accurate than a grain of sand to the moon, so we should use fractions. But on the other hand, if you don't want, if you need slightly less accuracy and you can live with that slight error, then maybe it makes sense to take literally 10,000 less time, right? It's literally a factor of 10,000 between the time it took with fractions and the time it took to precisions, for only 10 to the minus 14, right? So fractions are really, really, really slow in some algorithms, really slow. I was going originally to show the example with 1 million, and again, like, my patience failed me. It doesn't go linearly, it goes quadratically, so it's really, really bad. And like I said, like, eventually I was afraid of damaging my computer's fans. So fractions also have issues. Now let's think that you have decimals, and decimals are great, right? Especially if you want to manage money. And so I literally copied and pasted this from the official documentation that shows how the precision is managed in Python in decimal. This is literally copy and paste. If you compare it, the only difference will be the font, because I re-rendered it, but it's character for character identical to what you get from doc.python.org. And you can see that I changed here the precision to 6. I calculated 1/7 in decimal. It gives you this value. If you set the precision to 28, it gives you, you'll have to trust me that this is 28 places under the decimal point. Again, this is all reasonable. But as many of us know, because we go to doc.python.org, the documentation doc.python.org is good, but not great, right? It could be improved. So I thought maybe I can improve the documentation here. So I tried to improve the documentation. I'm not sure I'm making an official patch. Maybe we can discuss it later on the channel. But here's my proposal for an update to the documentation. This is more realistic, right? You set the precision to 6, then you have 120 lines, then you divide 1/7, then you set the precision to 28, then you have another 500 lines of code, and then you divide 1/7. And as you can see, this is exactly the same documentation, just eliding the more realistic. There's more lines of code in your program that probably do stuff with the decimal, or grabs the values from somewhere, or push it somewhere else, or grab it from an API, or read it from a file, or whatever it is you need to do to get these numbers. And the person reading your code might get lost and not remember that you set the precision to 28, 500 lines ago, especially when they saw that the first line of the code was setting the precision to 6, and might be really, really surprised of, like, the precision being 28. So this is a fun part of a hidden state in decimal. Now, if you have a really tall monitor that can show all these lines, that's fine. I prefer to work with smaller laptops, especially now that I work from home, and I literally, my rig is my laptop, my screen, my lap. So I need to some code that will work with that setup. So there is a way to use, and the only reasonable way to use, if you expect someone to not have a screen that's about 3 feet tall, or 1 meter for your Europeans, then you want to use local context, right? So you want to use decimal.local context as context, and then you explicitly set the precision. And now you can see that the precision is 10, and we have 10 digits, not 6. So this is the only reasonable way to use decimals, because you cannot know where on top of the file someone says the precision, or someone imported your library into something that says the precision, or a library says the precision. Who knows what can happen? This is like perfect action at a distance. The only reasonable way is before you start any computation with decimals, you set the local context, and then you do the computation. And that's tricky, right? Because you might be calling something and stuff like that. So you have to remember to do that. Okay, so this is most of what I wanted to talk about. But I'm going to leave you with final thoughts, right? A lot of people expect numbers to be straightforward. Numbers are really, really not straightforward, right? Ints degrade into floats pretty much spontaneously. Floats do not obey the laws of computation that you learned when you were in like 4th grade or whatever. Rationals do obey the laws, but basically like a lot of very straightforward computations will explode unless you do something very, very explicit to stop them from exploding. Decimal point numbers have weird hidden global that changes how they compute, reasonable stuff like division or addition. All numbers have some subtleties about them. So before you use numbers in your code, spend 5 seconds, think about what you're doing. Think about what kind of numbers. Think about what Python type you assigned to it. Think of what behavior you expect and whether that behavior is the behavior that you want or whether you should change the behavior. And I think I'm both out of time and out of slides. So thank you all for listening to my talk.
Thanks, Moshe.
You're welcome, yeah. And I'm going to stop sharing, but if there were any questions and if I have time for questions, I'm happy to take them.
No, actually, you are right. We are a bit, we have to finish this before the break, so we don't have much time. Please take questions in the chat if you like, the questions and answers channel. So the next talk is Jason. He's the author of the Discord setup. All this, the nice descriptions of the rooms, and he did a really nice job. Yeah.
Yeah, the roles, the colors, the channels, everything.
Oh, I forgot. He has to raise his hand because
no,
he's here. He's here.
Yeah, I'm here.
Okay.
Hi.
Yes.
I didn't. Code mouse. Okay. So function meets objects.
So you can see everything. That's awesome. Wow. Okay. Well, I'm really excited. Although I have to say, Moshe set the bar really high on humorous delivery, so everything can only go down from there. So, hello everyone. I'm really happy to be here. So I wanted to talk to you about functional and object-oriented programming in Python. You're not going to have to look far to find someone who's done object-oriented programming in Python. They're probably sitting in your chair right now. So I really don't need to say much about that. So what's this functional thing? Some people have used functional. The enlightened among us know what this is. The rest of us just have a vague idea. It has something to do with lambdas. And it seems like the two paradigms are at odds. You're going to find a lot of warring between the two factions. And I think this is rather unnecessary. Because when I learned functional, I realized it actually informed my object-oriented code. So I think there's a way to combine the two together quite beautifully. So a little bit about me is that I am trying to get my slide to respond to me. There we go. My name is Jason McDonald. My personal website is indeliblepluepen.com. I like to say I'm an author, speaker, hacker, and Time Lord. Look at the website to understand what that last one has to do with. I am the lead developer at mousepawmedia.com, where I train interns and just generally have fun writing open source code. You've probably encountered me on Dev if you're on dev.to, CodeMouse92 on there. I'm the author of the popular Dead Simple Python series, which is soon to be a book from No Starch Press. So if you're a book nerd like me, be on the lookout for that. And you can also find me on Twitter. It's CodeMouse92. I'm just about everywhere online as CodeMouse92, so you can find me pretty easy. I also tend to hang out in IRC a lot, so check out Freenode if you want to pick my brains. So to understand how we can combine these two together, we have to start by quickly recapping object-oriented programming. And the central tenet of it is encapsulation, having data and having the methods that work on that data being in the same unit. Where we don't have to understand how we're working with the data, we just need to work with the handy little methods that are provided to us. I really like the analogy of a microwave. You don't have to understand the coils and all that stuff. You just know to type in the time and press start. That's a great example of an object. And it gives us excellent reusability. And when we design a class well, it should have one single responsibility. Typically, you want to think of it as if you were creating a data type. That's how I usually approach writing objects. But if it can easily get out of hand, you can wind up with unpredictable code if you're not very careful with how you do object-oriented, because you have these complex relationship structures with composition and inheritance. You don't know who's managing what, and you just generally wind up with a big hairy mess if you're not really, really cautious. Mutability makes this worse. And if you've ever worked with lists in Python and trying to pass a list or use a list as a default argument, you know what I'm talking about. Mutability can be a royal pain, which leads many to demonize object-oriented programming. The answer, the enlightened would say, is found in functional programming, which is purity of function and of heart. The central tenet of functional programming is having no side effects. When you pass in arguments to a function, the function should never mutate, never change any of those arguments. It should instead produce a brand new value, I can speech, and return it. Pure functions also need to be stateless. Actually, I think I'm gonna piggyback on Moshe's example really quick. He mentioned decimal and how it uses this this thing that you can set this context on it, with how, what the precision is on it. And that's going to change how decimal handles numbers. That is the exact opposite of stateless, because you can wind up changing something else somewhere else in the code that affects how that function behaves. And that's bad. That can lead to really confusing code. Pure functions don't have any state. The only data they ever work with is the data that's explicitly passed to them. As a result, they're repeatable. So f of x is going to give us y every single time without any surprises. And they're isolated. So calling f is not going to affect the execution of function g. As with objects, they're reusable, and a good pure function should have one single responsibility. If it needs to go beyond that, it calls another function. But this is not necessarily a magic bullet, even though some would like us to believe it is, because you wind up with some performance issues sometimes, especially when you're dealing with immutability and large data sets. You wind up producing all of this, you wind up duplicating your data set, and that can lead to slowdowns. Some patterns are impossible to implement effectively in functional programming because of the lack of mutability. It can be difficult to think about. GUIs are inherently object-oriented. You could do functional GUIs. It's been done, but it's not easy because structure is really hard to grasp in functional unless you already know the paradigm really well. Even some functional developers say if you have to ask about structure, you don't understand functional. Well, of course, that's why I'm asking. Which leaves the rest of us wondering, what do you do with the state? Because all programs have state. Where do you put it? Answer: in global. So we obviously need a bit of a solution. See, this might not be the answer to everything, but functional programming is about purity, writing pure, repeatable, stateless functions, whereas object-oriented programming is about structure, at which point we can say that it's really not fair to be demonizing it like we tend to do. So if we were to combine these two things together, I'm going to redefine one thing. And we typically think of objects as encapsulating data. Let's just say an object encapsulates state. And if you know functional, you're going to see where I'm going with this. Two ways we can handle this. One is we could just write immutable objects. Now, if you want to learn how to do that, Mike Driscoll has a great article on how to create immutable classes in Python. There's some nice libraries, but I'm not doing that. I want mutability. So I want predictable mutability, getting away from this madness of not knowing when something's going to change. So when we're trying to bring this no side effects rule into object-oriented programming, the first thing that we have to do is remember our functions always have to be pure. A function should never mutate its arguments, period. However, methods can mutate self. They can't mutate anything else, but they can mutate self. In fact, I would even take this a little further, optionally, and say that write your methods to always mutate self, because this creates a syntactic sugar for us. And x.f that method call now becomes effectively in our minds the same as reassigning the value of x. We know x is going to be changed by this. What about our get-only properties, our getters? Just make them properties instead of methods, because x.a, that's not going to change anything. So it separates it out, and we know when x is going to be mutated. But when we're doing this, then we have to have a rule of never calling methods on arguments. Functions are supposed to be pure. So a function should never call a method on one of its arguments. Then we don't have to worry about side effects. Although, again, it can call methods on self. That's fine. It's already expected that the object's going to be changed by the method call, so a method can call other methods. You can get around the mutability issues that you typically have just by avoiding assigning mutables as much as possible. Just pass them. Don't mutate them. There's exceptions, but most of the time, just avoid it. So then how do we deal with this stateless, which is the other half of this, statelessness? Turns out we're actually already good here because self is an argument. So a method doesn't have any state, or shouldn't have any state. It instead uses self. It uses the state contributed by the argument self. It doesn't look at global state. In fact, it should never be looking at global state. And if this is feeling ooky to the functional programmers, hey, we already excuse closures. So functions, at least you can inspect their state. Closures, you can't inspect their state. So this is totally normal. There might be some, like, a little bit alarmed. I hope I'm not going over time here, but some people might go, okay, well, method calls are not commutative. You change the order and it's going to change things. Yeah, well, so was reassignment. So nothing's really changed there. But we can still safely say that function calls are commutative, as are properties. So just quickly recapping then, what are the benefits? Why bother at all? Well, by combining it in this way, we're going to gain the organizational skills we like having in object-oriented programming, but we gain the purity and predictability of functional programming. So we combine the two together, and we now gain the benefits of mutability in a predictable fashion without any sort of surprises. So I think combining the two together, you can get some much more maintainable code. So I'll be in Discord question and answer room. If anyone has any questions, I'll probably just spin off a functional meets objects talk room. So thank you very much.
Nice talk, Jason. Thanks. So next speaker of the session, last one of the session, it's Ken. Are you there?
You're muted. I can unmute you. Oh.
There, sorry.
Okay.
I think we were, okay. Can you hear me okay?
Yes.
Yep. Thank you.
Great, let's see, and then I can share my screen.
So Ken is going to talk about teaching test-driven development with PyTest.
Right. So I'm coming to you today from Tucson, Arizona, where I work at the University of Arizona. I like what Moshe said, so I'll recognize that this is the ancestral home of the Tohono O'odham Nation. And here at the university, I've had the privilege over the last few years of helping non-computer science major people to learn programming, mostly using Python. In the early days, we also taught a little bit of Perl. And so I want to talk to you about what I think is an effective way of using test-driven development and the PyTest module to help students learn. Everything that I'm talking about today, I've put into a GitHub repository, and I'll repeat that at the end of this talk, and including these slides and some code I'm going to share with you. So for instance, I might tell my students that they need to write a program called add.py, and it needs to take 2 integer values as positional command line arguments, and then it should show a little formula that shows the results of adding those 2 things together. So right away, there's a lot of things that need to happen, especially for a beginner to understand how to write a Python program, one that will accept command line arguments and run on the command line, and then we'll properly add these because as we know, when you're working on the command line, the 1 and the 2 come in as strings. So if they're not properly converted to integer values, then we could end up printing 1 + 2 = 12 because the plus sign is both an integer addition and string concatenation. So there's a lot of things to actually work in and to understand in even such a very simple program. And so one of the ways that I teach students how to write is that I provide them a test suite that will tell them when their program is not working correctly. All of this comes from the ideas of test-driven development, which was a book that came out, I think in the early 2000s now by Kent Beck. And the basic idea is that before you write a piece of code, you first write a test. So you imagine that there's some function you need to write, and it's going to add 2 numbers. Well, you can imagine from the outside, you want to be able to call this add function or this add program. You want to pass 2 numbers, and you expect to get back the sum. So you write that as a test. And then you run the test, and you verify, yes, my program completely fails. It's not going to add these 2 numbers. Then you go write the code that satisfies that test, and then you run the test again. And when it works, then you've successfully added a new feature to your program, or you've written some program. And then the nice thing is that there's this additional step where now that you have a program that works, that's tested, that you know it does what it's supposed to do, you can go back and refactor your code, try to make it better, and always come back to your test to make sure that your code still does what it expects. And then you just repeat this ad nauseum for every new feature that you want to add to your program. So I would give my students a specification. I'll write a README file, and I'll say, you're going to write a program that accepts 2 valid integers from the command line. When I ask for a usage statement, like with -h or --help, I expect to get that back. And then if everything is okay, it should correctly sum and show me the sum of these 2 values. So for instance, I would expect if I run this add.py program with only 1 number, it's going to give me a usage. It's going to say, hey, I expect 2 ints, and you only gave me 1. So I'm missing this required argument of an integer. Here in the second example, I've given 2 arguments, but one of them is not an integer. And the program just says, nope, I cannot add these 2 things together. That doesn't make sense. The second thing here, as far as the specifications, is that I expect my students to create programs that are documented, in that I should be able to ask the program, how do I use you? And pretty much -h and --help are the universal flags for asking for this, this kind of information. So I show them, I expect to be able to run your program with -h and see something like this. And if you're familiar with programming on the command line, you probably immediately recognize this as the output from the argparse module.